Okay, so we're doing another example related to using a normal distribution type of situation to compute probability. And well, let's read it. According to the CDC, only 40.4% of patients are seen in less than 15 minutes in an emergency department. Suppose the local hospital, now as I read this, I'm going to pull the information out. Suppose the local hospital has a total time in the emergency department of 154.8 minutes with a standard deviation of 63.2. So this should say mean or average time, but this is our average. And it's an average for the local hospital altogether. So this is our population, okay? The population is all patients or all the whole time patients are seen in that hospital. So it's a population mean mu, which is 154.8, and then minutes. Obviously, I'm not going to put the units, and the standard deviation population standard deviation of 63.2. I'm converting my words into my notation. Then the patient is released for additional care or recovery. We will assume it fits a normal distribution, which obviously has to be, otherwise I can't use these methods. What percent, circle that right there, of patients spent more than 254 minutes in the ER? Okay, they're asking for a percent, which means it's like probability, percentage. That means when we're dealing with normal distribution situations, we want area, okay? So anytime we want percentage, anytime we want percentage or we want probability, we want area, same thing. So if I were to draw the curve, which is something that I like to do because I'm a visual person, and you don't have to do this every time, but it's nice to see. So this is a normal distribution curve, and the center of this curve is my mean, which in this particular situation is 154.8. Now, the situation or the number that I'm doing is 254, right? I want to deal with a percentage that's more than 254. I like to put my center on my normal distribution curve as a reference, right? It's always my mean. So I know that 254 is over here to the right of that, okay? Over in the right tail somewhere. Figure not perfect. It doesn't have to be, perfect. This is literally just for reference. So being that I want percentage more than that, and I want area more than this value, the area would be to the right of it. So this is the shaded region. This is the area that I want for this particular situation. And every time I want area, we know that we use our calculator trick called normal CDF. Okay. Now, if you guys know normal CDF, and I'll do it on the calculator second, you always have to, bound the area to which you want to find the value for. So my lower bound here would be 254. My upper bound would be positive infinity, because technically this continues forever in the right direction. Now, we don't typically have positive infinity in our calculator, so we use a very large positive number, which we represent as 1E99. I'll show you how to do that on your calculator. This is scientific notation on your calculator, saying that you have a 1 with 99 zeros after it. Okay, so it's a large positive number. Then we have to tell it the mean, 154.8, and then comma, the standard deviation, 63.2. So those of you that have to put it this way, you have to know the order in which you have to input your values. So let's look over here. So we're going to find normal CDF when we do second vars, and you'll find normal CDF number 2. And like I said, not all of you guys have this lower upper process or availability, so you have to know the order in which to put it. But the lower is 254, the upper, you see how you do 1E, let me rewind that, 1E99. So you press 1, and then second, and then comma to get that E, and then 99. It's above the comma here to get that E. That represents scientific notation in your calculator. Then you do in your mean of 154.8 and your standard deviation of 63.2. And when you enter on paste, you're going to have the same thing I wrote here, and enter again, and you have your probability or your value, or your area, I should say, to the right of 254 on this particular curve, which is approximately 0.0583. Now, it doesn't tell us how to round. We always want to make sure we pay attention to how we're asked to round. Typically with probability, with percentage, with area, we want to do 3 to 4 digits to the right of the decimal. So I'm taking 4.0583. But because they asked me for percent, I'm going to convert that into a percent as 5.83%. Okay. So, I want to answer the question based on the question. If they said, what is the probability, or what percentage or what probability of patients spend more than 254, I would leave it in decimal form. If it didn't ask me for percentage, if it just asked for area, I'd probably leave it in decimal form. But because it's asking for percentage, we want to convert it. Okay, so always, answer the question based on how they ask for it. Make sure you check for your rounding process too, or your rounding rule.